Welcome to the another session in Frontiers in CFD. CFD simulation of paraffin wax based PCM battery thermal management system for efficient cooling. So the objective is to prepare the geometry of PCM based battery thermal management system to generate the mesh on computational domain, checking the proper element size domain and specify the name selection to run the setup and visualize the results for the PCM based battery thermal management system. So welcome you all to another session on Frontiers in CFD. Today we will see the CFD simulation for thermal management of lithium-ion battery, which enclosed in a PCM. So let's click on geometry, click on new design modular geometry. Okay, first of all set the units to millimeter. Then I will start with one of the box. Let's create, instead of add material, I will put add to frozen. So I just take it around 320 as a dimension of the box. Y component I will take 65, Z component I will take it around 82, and let's proceed. Okay, so you can see the object has been generated as a box. So I need to prepare sketch. So one by one I will proceed. So first of all, draw a circle here with some diameter, let us say equal to 80. Then dimensions of center of circle from one end, that I will specify, say from this end. So that is, I will take it 41 here. Then from this end to this end also I will specify the distance to be equal to 41 here. Okay, so now the geometry has been prepared. So let's click on the first sketch has been prepared. Now I need to draw circles along this. So first of all, create one horizontal line, vertical line. So specify the dimension, that is equal to 24. Then draw a circle of radius 18. So draw a circle here of radius 18. So specify the dimension. Now I need to draw this in multiple numbers. So let's go to the copy options. So select this and select this. So set face handle at center. So I need to specify the angle, let us say around 60, and accordingly now I will rotate this. So here will be the point. Then I will rotate it one more time. So will be somewhere here. One more time, rotate it. One more time, rotate it. So let's take it here. One more time, rotate. Yeah. So this is what I tried to generate. Let's rotate it by minus R. Let's rotate it here and let's put it on this side. Okay, so it is showing error. So I will just do this manually. So simply draw a line from this here and vertical line. Just take the distance that is equal to 24 here. Then draw a circle here with same radius. Now I will try to remove some of the lines which are there. So this is just for reference we are drawn. So later on we don't require it. So this one. Okay, I just try to remove this line which are not required for us later on. Yeah. Now we'll draw one line from this to the other one. Let us say 24. So this is 24. Now I'll copy all the circles on this. So go to the modify. Let's say copy the first circle, second circle, third circle, fourth circle, here, and this one. So from this I will shift it here. Okay, so the first layer has been drawn. Similarly, I will draw one more line from this here, dimensions should be 24. So let's specify this is to be 24. Then click copy, select all circles which we are having here, this one, set first handle from here to the third one, click on end. One more time, one more line has to be drawn. So let's vertical line, give the dimension, sorry, horizontal line, dimensions to be equal to 24. Then modify, click on copy, 1 2 3 4, this is 5 6 and this is 7. So set the first handle and here. So let's click on end, remove the unnecessary lines which we don't require now. So this is not required, this is not required, this is again this sorry, the circles is not required as of now. So these lines are not required in between. So ensure that each and everything is done properly. Observe the sketch once and then go to the extrude operation, click on apply and click on slice material. Just specify the value which is equal to 65 and let's click on generate. Now you will see this has been separated out. Now I will generate one more sketch here. So sketching, go to the circle one more time. Now I will select the dimension that is around 40. So go and specify the dimension here. Sorry, 80, not 40. So one more circle I need to draw. I just need to copy the circle. So let's click on copy option. Let's say select this, set first handle from this here, here and this one. Click on end. Remove the unnecessary things which are not required for us. So this is the thing which is not required. So in between I am just removing the things. Okay, so the remaining portion will try to make this as a PCM. So let's click on generate and let's one more time click on extrude. Instead of add material, let's make it slice material and generate. So you can see it has been generated now. Now I've just slightly reduced the dimension which is on the other side. So this is the box which we are having. So let us say if I take it 310, it will, or take it 300. Okay, so I took it 300. Now the rest of the things I don't require. I require cells and I will consider this as a PCM material. So likewise I will proceed with the simulation part. So I just click this solid part which is on the outer side which is not required. I click on body delete, make it apply and generate. So you can see now this is how the structure has been prepared. Now one by one I will define the cells 1 2 3 4 5 6 7 8. So select all cells and define form new part. So let's click on form new part. So I will just rename this as cell and the other one I will rename as PCM. So mention this as your PCM. So I will give the same name for each and every place which is on this side. So select Control V. So select Control V here, then Control V here. So define name, same name to each and every cell so that you will not be having multiple boundary conditions in the setup. Otherwise if you put cell 1 to cell 3 like so on, so this will results in multiple boundary conditions. You need to enter more values in the setup part. So that's why I put a common name to avoid the entering the multiple boundary conditions. So let's click on this one here. let's click on this cell. So each and every place you have to put it. You can have some different cross section also, where uh, you may have the fluid which is flowing through these channels. So likewise also it can be modified. So but we are now just doing with the PCM. So let's click on all of them here. So at all places you need to make it cell to avoid the multiple boundary conditions. So now, as far as the geometry is concerned, we are done with the all things. So we have defined the cell as well as we have defined the PCM. Okay, the process of geometry preparation has been done. Now we'll move to the next part. That is, first of all, we'll save the work and then we'll move to the next part. So click on new. So I have 28 cell with PCM. So I will say a name mention here, 28 cell with PCM. So copy, make it 28 cell with PCM. So save the work. Once you have saved the work, you can proceed for the next step, that is related to the generation of mesh. So click on edit. Okay, it shows some error, so I had to open it again. So close the meshing. So open the mesh part, click on edit. So now you can see the mesh has been loaded. The geometry has been loaded in the mesh. So fit to seam. So let's click on generate. First we will generate the default mesh and then we'll see how uh, the mesh comes, and accordingly we'll change the element size. Okay, so now the statistics looks to be around 69,178. So may not be satisfactory. So I just took it 0.005 and let's make it generate. So the mesh count may be higher in terms of nodes and element. So no such variations. I will put it 0.001. Let's make it generate. So the mesh now has been generated. So 23,54,581. So this is the number of nodes and element. We'll try with some intermediate value also, 0.025. Let's make it generate. So that we can go with 23 lakh also, but time requirement may be slightly on the higher side. Okay, so this looks to be slightly on the coarser side. So let's make it fine. Okay, so this, so I will go back to again 0.001, or you may take it in between like 0.0015, so as to have some better mesh with some more accurate result also. We can proceed with this mesh also, but the time requirement will be slightly on the higher side. So 0.001, it looks to be quite better than all the remaining. So 23 lakhs is there, so we can actually proceed with this. So let's proceed with the same. Okay, so what I will do now, I will just hide the PCM, hide body. I will left with only cells. So I will select all cell walls here. So select all cell walls on this side. And I will define them as cell boundary. Okay, so I will define them as cell boundary. So let's click on create name selection, mention this as cell boundary. Okay, so once this is done, I will make it show all bodies, and I will click on update. So you will see a message that will be a mesh translation to Fluent successful. Once that message appears, you can close the window and you can proceed for the next step. So we are dealing with cell with PCM. You can actually further modify the element size here depending on the capabilities with your computer. So I stick with 0.001 and accordingly will proceed. Okay, the next step is for setup. So click on double precision. I put it somewhere around 16 number of solar processes. Click on start button. So depending on the processes available with your computer, you can select that value. So the PCM that we are going to use is the Paraffin wax liquid. So that is the material that we are will going to specify: paraffin wax liquid and paraffin wax solid. Okay, so first of all set the transient mode, then put the gravity, that is minus 9.81. So gravity we have to specify, that is minus 9.81. Okay, so just go to the model, turn the energy equation on, so make it okay. Viscous, we need to select the K epsilon model, enhance wall treatment, thermal effect, lastly is your curvature correction, so make it okay. Then one more thing that we want to turn on is the solidification melting. Let's make it on. Okay. Okay. So next step is your material. So go to the material mode. So I will just select here the paraffin wax. First of all, this is the fluid zone. I will set paraffin wax like liquid. Similarly here also I will write the same, wax like liquid, and use the value of density available. So I just put 790. Specific heat I will put 2150. Thermal conductivity I take it 0.22. Viscosity I will take 0.01. Then pure solvent melting heat I will 240800. Solidus temperature I will put 313.6. Liquidus temperature I will put 313. 7.7. Okay, so once this is done, click on change create, make it okay. Okay, now next is paraffin wax. So I just go here, select lithium battery. So select here lithium battery. So put the values 2775, and then I will put it 880, and this is 3 watt per meter Kelvin. So let's make it okay. Then one more time we need to define the paraffin wax solid. So let's go for solid. I will just add aluminum, make it close, and we'll change the properties here. So put it paraffin wax solid. So let's here also. So use the values for solid. So 880, then this is 2000, and this is your 0.2. So this is 2000. Just a minute. So make it change create, make it okay. This one more time, just check it here. Okay. So now this is done. Let's define the cell zones. So zone type. So cell, it is your solid. So turn this to solid. Okay. Taking some time. Let's wait for it. Okay. So let's go to the PCM. So we'll define the PCM fluid which has been present. Paraffin wax liquid. So let's click on apply. Then close. Cell, you are going to define this solid. So lithium battery source term. I will go here, and number of source terms I will just put it to 1. Here I will put the value of heat generation, that is 104017. Let's make it apply and then click on close. Now go to the boundary conditions. So zone type, it is by default it has been available. So select, so lithium battery is there. So cell boundary contact region, whichever you are observing, so there must be lithium battery there. So that's one careful thing we have to do. Wall cell, you can just check lithium battery should be there. Okay, it is there. Wall PCM, if it is not there, lithium say PCM solid, you have to change that to PCM solid. Okay, so let's make it paraffin wax solid. Let's apply and then close. Okay, so now next thing is the report definition. So click on surface report, area weighted average, then temperature. I will select the total temperature and select all. So print to console. So here I will specify the total temperature system, report definition 0. So this is useful in order to know the total temperature of system. Next, surface report, area weighted average. I need temperature of cell. So I will select total temperature. Now I will select all cell boundary contact region to get the temperature of cell. Then along with I need to select the wall cell also. So as the number of cells are more, this process will become slightly lengthier. So it will be very useful that if you are specifying this in the mesh where we have done the cell boundary as a contact region. So I will put it cell temperature report definition 0. So let's make it okay. Similarly, we have to do solidification melting for PCM also, but right now we don't know which one is exact region for PCM, so that's why I'm skipping this step, and we'll go back to uh, it again once we do the initialization. Okay, so let's first click on initialize and then go back to the report definition again for solidification melting. So click on autosave, let us say 20, go to the solution animation, select contours. So as it is first temperature, here it is total temperature, select all, go to the color map option. If you don't want to see the exponential scale, select the float, make it apply and then close. Click on save display. make it close and select the contours, put it total temperature animation. So let's make it okay. Then one more time, just click it here, new object. So now total temperature, I will just select cell temperature, so slightly make it bigger. Okay, so selecting wall cell, so go to the color map option, instead of exponential select it float, make it apply, then close, click on save display, then close, go to the contour, specify cell temperature animation, let's make it okay. One more time, now go inside new object contours. Now I will go with the solidification melting liquid fraction. Now we need to know where the liquid fraction is present, so that's why this step is now involved. So let's select wall PCM now. Okay, so let's, I just click on display, you will see only the frame is been visible. I need to visualize the contact regions also. So contact region 9 SRC I selected, so you can see somewhere here this has been filled. So one more time, select all that. Okay, just observe some changes that is been taking place. You can see now it is properly visible. So select all remaining. This will come to know only when we are in the animation mode, and that's why I will go back to report definition now, and then we'll do the remaining operations. So contact region SRC I'll selecting. So all are been selected. Now you can see it is properly visible. Now you can go and set the solidification melting also. So go to the color map option, select float, make it apply, and then close, click on save display, click on close, contour 3. I will see the solidification melting animation. Click on OK. Then now go back to your report definition one more time. So surface report, area weighted average. Now I'll select solidification melting. So first we'll select wall PCM. So mention is solidification melting. So select wall PCM. Then contact region, so I will select here. Okay, so let's make it okay and then close. Now go to the run calculation. Simply put, initially let's put some smaller value, let us say 10. Later on you can make it big, and let's click on calculate. So this may take some long time as per the solidification and melting point and the heat generation rate we have taken. So we'll just have to wait once the results are appearing. So for first 20 iterations when they are been performed, you will see the different windows that will be visible here. So let's wait for it. You will see now here the iteration will process will start, that is 1 2 3 4 5 6 7 8. Once the first 20 are completed, that time you will see changes in this particular window. So till that time we have to wait. You can see now 19, 18, 17 and so on. So this, once this is completed to 20, you will see a separate window that will be appearing, which will show the cell temperature curve, it will show the solidification melting curve, it will show the total temperature curve, and it will show all three animation like solidification melting, then total temperature system and cell temperature system of the, we can say, the system. So that will be shown over there once this is completed to 20. So now 8 9 8 7. So once this is completed, so you will see the different windows that will appear here, and accordingly now we can run the simulation for some long time. You can see now 2 is left. So once 1 is being completed, you will see all the windows are appearing here. Yeah, you can see now. So there is uh, initially there is no liquid phase present. So this is you shows the total temperature of system. Second shows you cell temperatures. Then this shows you the liquid fraction. As of now, the melting hasn't taken place, so that's why you will not see anything. All will show 0. Then solidification melting curve, it is again flat as of now because the melting hasn't started. Then this is a total temperature, cell temperatures curve. So this is rising. Then we will have a total temperature system curve which is also rising. So we'll have to wait for some time in order to visualize the result. So gradually you may see the heat is when coming from the cell to the PCM. So we'll have to wait and then we'll visualize the result. So we have performed the iterations for around 1200 seconds. So for this flow time, you can see the total temperature is system curve. This is the first one. You can see the temperature reaches to around 317.76. Then contours of cell temperatures. Then you have the PCM liquid fraction which is available, so that can be visualized here. This is the liquid fraction curve. You can see the melting has took place. Then this is the cell temperature, so it's trying to become flat after some time. So next one, it is your the total temperature of system. So the curve is trying to become flat. So these are the scale residual which we had. So up to this now the iterations have been performed, and accordingly you can visualize for around 1200 seconds. So this is how the cell temperatures and the animation window, liquid fraction, cell temperature curve, and the total temperature curve. Okay, so let's save the work. So once the work is saved, we'll see how to generate the reports. So we already set the report definition, we already set the animation. So now to generate the report, first we have to go to the animation window here. So you can see we have performed around 1201 say as a flow time. So just put this replay speed to lowest of the value, then go to the video file and go to the video options. So select the number of frames, I put it 60. So instead of original resolution, I select the custom one. So let's say 4K video. So quality is best. Then here also you select the best. So make it OK, and let's click on OK. So this is how you can set the videos for generation of the report. Next thing, you will see total temperature animation, cell temperature animation, then solidification melting. You can click on right here also and generate the videos. What I will do is I will go to the last option, that is simulation report. So in this case you will be having one option of report outline. Now in this case you will be generated with a PDF report along with the video files which we have been available, so that will be generated. So let's click on generate. So now this process may take some time, and whatever the folder we had, so in that folders, if I just go inside of the folder, so let us say, so we are doing with this 28 cell PCM, so you have to go inside of this, go to the DP0, go to the triple F, go to the Fluent. So in this folder you will see all the report definition will be there, as well as the temperature curves, as well as the animation videos will be saved in this particular folder. So we have to wait till the complete report is generated, and then I will visualize how the report it is. So we have completed the simulation for around 1201 seconds. So 1202 seconds. So you can see the cell total temperature system. This is the cell temperature. Then you can see the solidification melting curve, and you can say this is the value here. Say around 1200, 0.35 is the liquid fraction. Then this is the contours of liquid fraction. Next is the contours of cell temperature, and you can see the contours of total temperature system. So cell temperature curve, you can say it becoming flat after some time. Then this total temperature system will also trying to become flat. So over the period of time this will become flat, and you will see no further changes in the values of temperature. So the maximum peak value temperature, which is coming around 316 Kelvin. So this is all about the simulation. So this represents the contours of total temperature system. We can see the variations in the temperature. So this is the total temperature system report definition. So you can see how the curve is varying with respect to the flow time temperature curve. So this is the animation video which we can visualize. So the maximum temperature that reaches around 317 or slightly more than that. So this is the complete video of the animation, how the heat has been transferred from the cell to the PCM, and how the heat has been taken by the PCM. So likewise the variations we can observe. Next is the cell temperature animation image. You can see again the variations of temperature. So this is the cell temperature curve, how it becomes flat after some time. So that is the video visualization we can have. Apart from that, we can visualize the cell temperature, how it is varying with respect to the flow time. At the bottom you will see the flow time which is available, and you can see some variations in the color contours also. So the next is your liquid fraction animation image. You can see the liquid fraction curve. So approximately before 600 the liquefaction starts, and now you can visualize the animation where, or the video where the liquid fraction will be visible after around 500 to 600 range, and then you will see the liquid fraction is been visible here. So this is what the simulation is. So we are on it around 1200 seconds.